Good morning everyone, we are the PEDOCI, the Italian on-stage advanced team from Itis Carrozzo from Venice. I'm Sara and this is Omar, and we take care of the electronic part of the project.
I am Eduardo and this is Lisa, and we take care of the software part.
Our project aims to bring a typical symbol of our city, Venice, thanks to four main actors: the gondola, the Lion of St. Mark, the Masquerata, the Dancing Queen, and the dynamic scenery.
Our video will be divided into three parts: the hardware, software, and the four features.
The gondola is the leading actor of our project, equipped with a Raspberry Pi 4 that controls two motors with encoders for wheel movement, using 2H bridges. Additionally, the gondola features servo motors that enable the mechanism to raise its side banks. Communication with the other robots occurs via a Bluetooth module.
The Lion of St. Mark is equipped with OmniWheels, allowing it to move freely on the stage. Its brain is an Arduino Mega 2560, which enables the gesture sensor to recognize certain gestures and perform actions based on them.
Here we are in St. Mark's Square, where the famous carnival takes place every year.
Additionally, the Arduino is the central node of the Star network and serves as the master of Bluetooth communication among all the robots in the project, coordinating them.
The Dancing Queen is a robot capable of auto-throttling, maintaining balance on two wheels. This ability is made possible by gyroscope that throws a PED, Prototype Integral Derivate Control System, constantly adjusts the robot position, allowing the start upgrading without external intervention. She starts moving thanks to RFID sensor.
The Masquerata typical Venetian boat is controlled by an Arduino Uno that manages the two wheels through an H-bridge. This robot is also equipped with a Bluetooth module to transmit distance information detected by the laser sensor to the Lion of the St. Mark.
There are other elements aimed at emphasizing the performance that can be found in St. Mark's Square. On the background, there is the St. Mark's Campanile, with its bells that ring, which are activated by an ultrasonic sensor, the fountain launches streamer using a fan, and the man and the woman turn up celebrating by means of a servo motor. All the robots introduced have been programmed using two languages, Python and C++. The code is organized into classes and functions to ensure modularity and ease of maintenance. Python was used to write the code for the gondola due to the need to develop an AI model using advanced libraries like OpenCV, allowing the gondola to identify the position of the ball and autonomously adjust the speed of its wheel to correct its trajectory. For the other robots, it was more suitable to use C++ and C as the standard languages for Arduino microcontrollers, which, thanks to appropriate libraries, allowed us to acquire and manage the various sensors and actuators. The gondola equipped with a webcam using OpenCV3 follows a red ball by identifying its position and adjusting wheel speed accordingly. The camera captures image to detect the red color, isolate the ball and calculate deviation from the center. This data is normalized and converted into PWM commands for real-time course correction.
The Masquerata uses a laser sensor to detect proximity to the gondola. If the distance falls below a preset value, it stops, drops anchor and sends a Bluetooth message. The Masquerata communicates with the Lion, a central node, which then forwards the alert to the gondola, ensuring centralized management and coordinating between the boats.
The Dancing Queen robot waiting in St. Mark's Square is invited via an RFID ticket. It uses a self-balancing system with PED control to move on two wheels toward the center. PED control regulates the robot's position using proportional, integral and derivative components, ensuring stable and precise movement by constantly analyzing gyroscope sensor data.
Main robots are equipped with RGB LEDs to visualize system status, confirm command receipt, and indicate issues or special situations. The programmable signaling system allows for customizable colors and sequences, playing a crucial role in visual communication and ensuring smooth operations.